Hello and welcome. We're going to try to help you now with cereal dilutions. Now, one of the things you're going to have to do in lab coming up is make a cereal dilution, and you're going to need to know what you're actually doing. So the idea behind a cereal dilution goes like this. You start with some solution that is your stock solution. The stock solution has a concentration of, I already forgot, 0.25, and we're going to use the units of molarity. And molarity, not molarity, molarity is moles of solute over liter of solution. So our concentration here is 0.25 molar. Now, we're going to dilute it. To do this dilution, we're going to take a certain portion of our stock solution and we're going to put it into an empty graduated cylinder or an empty piece of glassware next to it. But we want to know exactly how much of our stock solution we're pouring into this. And in this lab, we are going to be pouring over 2 milliliters of our stock solution. So let's just put some lines there. Look, it's a solution, it's cute. And we're going to pour 2 milliliters worth of our stock in. Now the next thing we're going to do to dilute it is add more water. So if we've got a beaker and it's got water, we're going to pour some of that right in up to our dilution level of 10 milliliters. So we're going to fill up to the mark that we're wanting to go to. Now let's do some math to figure out what the concentration of our first dilution is. Now if you're in Dr. Cyrus Barnett's class, I'm really sorry. You're going to see this from me. You're not going to see this from him. And he hates this, and I'm sorry. But we're going to do it anyways. This thing that he doesn't like, and he's sitting right over there, so he's getting to see this. The thing that we're going to do is M1V1 equals M2V2. This is the molarity of our starting solution and our volume of our starting solution, molarity of our second solution, volume of our second solution. Now the reason that this works is when you take molarity, remember, moles over liters, and if you multiply that by a volume in liters, it's going to equal moles over liters times liters. The liters end up canceling out, and the moles end up being the same. When we are doing a dilution, our moles end up being the same. That's how this ends up working out. So, let's do the math. For what we have versus what we want, we had a stock solution of 0.25 molar, right? Stock solution with effects. So stock solution, we're going to bring that right down here, 0.25 molar. We used how much volume of that?
2 milliliters.
2 milliliters. 2 milliliters. Okay? That is going to equal what we want. Now we don't know the concentration of what we want, but we do know the total volume of what we want. And
10 milliliters.
10 milliliters. So M2 is what we're going to solve for, and our volume 2 is going to be the 10 milliliters. Now the astute of you are noticing here, this is in milliliters, and we use liters up here.
Dun dun dun.
I like this. So you can now be saying, what do I do? Okay, if you are panicking right now, the thing to do is to go ahead and convert your milliliters into liters. And then it will definitely work out. Or the other thing you can do is leave both units the same and it will still work out. If you don't trust me, do the math both ways. It will end up working out. You solve now for M2, and whatever your value for M2 is, goes right here for your dilution concentration. And that's a number, and you have a calculator, and I don't. So you can calculate that thing. So this step right here, we did the math for. You can now repeat, keeping in mind what you have. Now this volume may change by however much you're using in your second solution. If you're not using 2, maybe you're using 4. Well, now the 4 would go right in here instead of 2.
And it's just that easy.